Imagine a future where American farmers, struggling to meet growing food demands, suddenly lose access to one of their most powerful tools: agricultural drones. These drones, many of which are made in China, have revolutionized farming by enabling precision pesticide application, reducing environmental impact, and boosting crop yields. Banning them would not only cripple these technological advances but also put our farmers at a severe disadvantage in the global market. Thank you for taking a minute to let us tell you about Chinese spray drones and their impact in American agriculture and farming. Here at UPass we created an agricultural pilots organization, focusing on the safety and standards of spray drone applications throughout the U.S. We believe that once the importance of this technology and safety is understood, banning this technology will be the last thing anyone would to consider. To set the magnitude of farming in the United States, currently there are nearly 347 million acres under seed, and around 28% are serviced by aerial application. Regardless if crop dusters, helicopters, or drones are used, airspace applications are controlled by the FAA and limited by chemicals that are EPA approved by aerial application. For the purpose of our message today, we would like to focus on the agricultural aerial drone application and its benefits to the American small and large farmers. Agricultural spray drones bring a multitude of benefits to the farm when they are incorporated. Let's start with air quality. Agricultural drones use batteries, which means they reduce farming carbon footprint. It eliminates airplane and diesel fuel in and around the crops, and contributes to more environmentally friendly farming practices. The use of drone allows targeted chemical spraying, and because they fly at 15 feet above the canopy, they have less drift for precise application of pesticides. Drones are not an all-or-nothing application. They allow for targeting specific areas that need treatment and reducing the overall amount of chemicals used. This precision minimizes environmental impact and reduces the risk of over-application, which can harm crops and cause pest resistance. By optimizing pesticide use, drones support integrated pest management strategies that are better for long-term soil health and biodiversity. Because of the micron diversity of agriculture drones and targeting only affected areas, drones help reduce the amount of pesticide runoff into nearby water sources, promoting more sustainable farming practices. Precision application means farmers use fewer chemicals, reducing the overall cost of pesticides. This efficiency translates into direct savings for farmers. Drones can cover large areas quickly, reducing the need for manual labor and the associated costs. This is particularly beneficial for large-scale operations where labor costs can be substantial. Agricultural drones can perform tasks much faster than traditional methods. For example, spraying large fields can be done in a fraction of the time it would take with ground-based equipment, allowing farmers to respond quickly to pest outbreaks. Drones also do not depend on the ground conditions where traditional booms can tear up a wet field. Agriculture drones can applicate timely to minimize possible crop damage. Drones can operate in low-light conditions, enabling farmers to spray crops outside of regular working hours, which is especially useful during peak seasons and working in and around bees. Finally, drones equipped with sensors can monitor crop health in real time, allowing for early detection of pest issues and timely pesticide application. This proactive approach helps maintain crop health and can prevent minor issues from becoming major problems. Drones allow for remote operation, keeping the pilot at a safe distance from harmful chemicals. This significantly reduces the risk of chemical exposure, which can lead to acute or chronic health issues, as opposed to operators who are hand-spraying chemicals, and increasing the risk of inhalation, skin contact, or ingestion, which can lead to immediate and long-term health hazards. While crop dusting pilots are usually in enclosed cockpits, they are still exposed to chemicals and have the possibility to expose everyone between the airport and the field when ferrying chemicals. There is also the risk of chemical drift affecting ground personnel, not to mention the number of crop dusting pilots who lose their lives annually. Finally, and maybe the most important, agriculture drones are creating jobs for the next generation of farmers. Currently UPass is in partnership with the Farm-i-tude curriculum, which is currently available in over 2,200 schools around the country. Agricultural drones are equipped with advanced imaging and data collection tools. This data can be used to analyze crop health, predict yields, and plan future planting and spraying schedules, leading to more informed decision-making. Agriculture drones are not only beneficial for large farms but also accessible for small and medium-sized operations. They offer a cost-effective alternative to expensive ground-based machinery, making advanced farming techniques accessible to more farmers. Our goal is to help the next generation of farmers help themselves to stay on the farm by leveraging technology to both their farms and other nearby farms. The main concern that congressmen and senators alike cite as to why they take the position to ban not just Chinese agricultural drones, but all Chinese drones from the American airspace, is national security concerns. The House's position has generally emphasizes immediate and broad-based restrictions to address perceived threats from foreign drone technology in the bill, H.R. 2864. While the Senate's focus is on 6438 and the Armed Services Committee defense policy and legislation related to drone security. So let's tackle both these concerns with reports and facts. In a report from NASA dated August 2018, they were tasked with a security review of specially built DJI drones for use by the U.S. Department of Interior to fight wildfires. They started with the assumption that the commercial DJI software running on the SUAS systems, by both iOS or Android, which communicates with the flight controller, was assumed to be inherently untrustworthy and from a potentially hostile foreign manufacturer with regard to the egress or exfiltration of flight data. There were provided DJI software versions from the Department of Interior that had reportedly been modified to prevent the applications from communicating with any of these questionable entities. The test described in this document was performed to capture and review all network traffic for the Department of Interior version of the DJI applications to ensure the concerns for data integrity mentioned are addressed. NASA found the Department of Interior version of the software did not communicate with servers in China and appears to prevent the disclosure of SUAS data to potentially hostile foreign entities. NASA's recommendation was to continue to use the Department of Interior Specification Government Edition software in conjunction with the existing foreign entity mitigation plans to ensure the highest level of network security. Then, in 2019, the Idaho National Laboratory, on contract from the U.S. Department of Homeland Security Cybersecurity and Infrastructure Security Agency, also conducted tests on the same built-to Department of the Interior Specification Government Edition DJI drones. On page 27 of their subsequent report, they indicated that no data leakage was found. Again in May of 2021, the Department of Defense conducted another analysis on the updated version of the DJI Government Edition drones to evaluate software including the new versions. The DoD report stated that the DJI Government Edition versions that were tested showed no malicious code or intent and are recommended use by government entities and forces working with U.S. services. Another concern is the ability to hack the agriculture drone and change the mixture to burn crops. This is why it's important to fully understand the benefits of the technology. Agriculture drone chemicals are hot-loaded, meaning that the pilot pre-mixes the chemical ratio based on label instructions and puts into the drone tank mixed, with a maximum drone application airtime of 15 minutes. The pilot knows how many acres can be covered in that 15 minutes with that load of chemicals. There is no fear of the drone being hacked. Even if the drone did have that potential, the only thing that could happen is the drone would disperse at a higher per gallons per acre ratio, which would immediately slow down the drone from a less gallons per acre ratio he may be running, and the pilot would know within minutes of the rate change. The safety of the Chinese drone technology has been tested time and time again, and every time, by every measure and every department, has been determined safe. From the American Petroleum Institute, the National Association of State Foresters, the Tech Associations, the Coalition for Drones in American Business, the Association of American Universities, the Association of Public Land Grant Universities, the Airborne Public Safety Association, the Law Enforcement Drone Association, and on have all written letters to Congress on the importance of drone security and their concerns over proposed country of origin bans that unlike widely accepted. Technical security frameworks do not ensure security and may actually reduce security by a free pass to drones produced in other countries that have not been properly vetted. But perhaps the piece written by Daniel Casro, titled "Limiting Drones Based on Their Country of Origin Does Not Make Anyone Safer," called out consequences of this misguided approach, which will hurt American citizens by eliminating the benefits of this technology. Focusing back on farming, what would be the impact if we banned all Chinese agricultural drones in the U.S.? Without access to agricultural drones, there would be a reduced efficiency in pesticide application. Simply put, application would revert to less effective and safe methods. This would increasing crop loss due to inability to treat pests and diseases at the proper time. Grounding Chinese agriculture drones would also delay essential farming operations. Besides spraying, all crop health monitoring drones are also Chinese technology. Again, not having access to this crop health information would lead to reduced crop yields. There will be the need for additional manual labor, or alternative methods, which can lead to delays due to lack of available workers, which again increases input costs and further exacerbating crop loss and higher prices. Precision application is largely driven by drone technology and has been shown to increase yields by optimizing inputs like seeds, fertilizers, and pesticides. Because drones are able to apply inputs with precision, meaning less loss, drift, less waste, without drones, yield reductions could result in significant revenue loss. Reduced crop yields could lead to supply shortages, potentially driving up prices, but also resulting in lost revenue for farmers unable to meet demand. So what is the wider economic impact? Reduced crop outputs affecting downstream industries, which translates to higher prices, including food processing and export markets, leading to broader economic consequences. The world considers agriculture drones as an integral part to modern agriculture. The grounding of Chinese-made drones could result in billions of dollars in lost revenue for American farmers. The US simply cannot compete with Chinese drones. We have not, and still are not, investing in our own precision agriculture drone technology options. Just as a note, current video you are watching is actual footage from a Chinese agriculture drone spot spraying parasitic vine that destroy potatoes and other crops, and can expand over 1/2 acre every 24 hours if not treated. Agriculture drones see the whole crop and only treat the infected areas, not overtreating the entire crop. Congress should carefully consider the broader implications before moving to ban Chinese agricultural drones. Such a decision could have significant economic, technological, and agricultural consequences. While concerns about national security and data privacy are legitimate, a complete ban will disrupt the agricultural sector, which heavily relies on these drones for precision farming, cost efficiency, and increased crop yields. These drones have become indispensable tools for American farmers, helping them maintain competitiveness in the global market through advanced technology that optimizes pesticide application, reduces waste, and supports sustainable farming practices. Moreover, a ban could stifle innovation and slow down the adoption of essential technologies, creating a gap that may not be quickly filled by domestic alternatives. Congress should instead work closely with the FAA to test new drones for airworthiness, and at the same time, with the direction of Department of Homeland Security setting criteria, work with the Department of Agriculture to determine the sensitive agricultural data that they currently protect from being shared from other collection methods such as aircraft, satellites, and fixed cameras. Then, confer with DHS on the technical security requirements that all drones engaged in agricultural spraying should meet. And finally, establish a clearinghouse where Chinese or any country building agriculture drone companies can submit their drones for testing and validation to those established agricultural spraying and data collection standards. This will allow farmers to continue having access to these critical tools. This balanced approach would protect national interests, without sacrificing the agricultural industry's productivity and the broader economic benefits it generates, and a more nuanced approach that enhances security while still enabling the use of Chinese agricultural drones, which is a more effective solution for protecting both national security and the vital interests of American agriculture. Let UPass help showcase this technology. Representing over 30 land-grant states, UPass pilots will host drone days and answer questions as to the value of this technology in farming. Our goal is to work with Congress to address all the fears of Chinese drones and their place in American farming.